Yo, what's up everyone? This is LeetCode 322 coin change. We've done this problem in Python. Now we're doing it in C++. So we're given an integer array coins representing coins of different denominations and an integer amount representing total amount of money. We have to return the fewest number of coins needed to make up that amount. If that amount cannot be made up by any combination of coins, return -1. You may assume that you have an infinite number of each kind of coin. Make sure you actually talk to your interviewer if you get this problem, if you can make this assumption, because if it's not explicitly stated like it is here, you might actually end up implementing an incorrect solution. Um, yeah, just a little interviewing, tip. Make sure you validate your assumptions. But anyways, so we have a bunch of coins, right? Can we make up this amount from these coins? Yeah, right. You might think, okay, let's use a bunch of ones, right? We could use 11 1 coins to make up amount, but that would not be the correct answer, right? Because you can use 3 coins, 5, 5, and 1 to make up the amount, okay? So, yeah, how are we going to solve this problem? Okay, that's what we're going to get into. So, you might think, okay, can I use a greedy approach to this problem? And actually, before I even get into this, right, let me talk about something really quick. This is a dynamic programming problem, okay? But it's also tagged as the breadth first search, okay? So why is this tagged as a breadth first search? We're not gonna use BFS to solve this problem, but I do want to discuss this just kind of quickly. Um, so if we have right the amount here 11, for example 1, right? We can have a bunch of different combinations, right? 5. Okay, so we have 10. We could have 9. What's a bad 9? 10, 9, 6, right? And we have a decision tree that keeps branching out, right? At some point, right, if we can make up amount with some combination of coins, we're gonna get 0, right? Um, in various places, assuming we can actually make those combinations. And the reason you could use BFS on this problem is because you basically would just find the shortest path that leads to 0, and that would be basically the minimum number of coins you need to make up amount. Okay, so that's why you can use BFS to solve this problem. Although, I'll be honest, I've never seen anyone use BFS to solve this problem. That's why it's tagged that way. In fact, I don't think it's really optimal or efficient, but yeah, that's why this problem is tagged that way. So you can do it that way if you want, but that's not optimal. So I'm not going to focus on that solution, but I still just want to point that out. But anyways, how do we solve this problem? Okay, let's get into that. So you might think we could use a greedy approach to solve this problem, right? But you actually can't, okay? And I'll show you why. So if we have these coins here, right, and we have an amount 8, if you use a greedy approach, you might use, okay, let's use the biggest coin. Okay, so we use a 5, then a 1, a 1, a 1, a 1 to make up amount, okay? So we have 8 here, 4 coins to make up 8. But that's not the correct solution because the correct solution is actually using 2 4 coins to make up amount, okay? So a greedy approach is actually not always going to work. So it's not the optimal approach, okay? So the way we're going to solve this is we're going to do this using basically a DP array, okay? And you can solve this recursively or iteratively. I'm going to solve this problem iteratively. You can do it recursively also though, but it's a little bit less efficient. And also I think it's a little bit less easy to read and understand. So I just don't think you should do it that way. I think it's more straightforward. Just use a DP array and do it iteratively. Okay. So the way we're going to do this is we're going to make our array. Okay. And our DP array. And how do we know what length to make our DP array? Just take amount plus 1, and that's the length of the array. Okay. So for example, amount is 1. So our DP array should be of size 12, which it is, right? Because again, we have a 0th index. So this is a size 12 array. Okay. And we want to populate everything with infinity, right? Just placeholder values. And then DP of 0, we want to make sure we set that to 0 as our base case because we need 0 coins to make the amount 0, right? So, okay, now we're done setting up our DP array. What do we do next? Okay. And the way we're going to do this, okay, is first of all, let's understand what everything in our array represents, okay? These indexes represent the amount we need to make, right? And the values in the array represent the minimum amount of coins needed to make up our amount, okay? So as you can imagine, our most important index is this last index. And we're going to build out this array basically iteratively, right? Like linearly. And the reason we do it this way is because we can use previously stored values to compute the current index that we're on, the value for the current index that we're on. And like, just think about this logically, right? Like if you have a tree, like a decision tree, right? If you have something here, if you computed like some combinations here that you also did here, why would you want to compute it again, right? And again, our decision tree here is simple, but it can get really big. And like just logically, like from like a dynamic programming perspective, right? The whole point of dynamic programming is to like reduce redundancy and like overhead and duplicate work, right? So that, you know, basically we solve sub problems, and we use those sub problems that we already solved to solve other sub problems that, you know, contain some like computation that we have to do that we already have done before, right? What I mean to tell you is like we can use stuff we've already solved to solve things later on that maybe we don't want to compute twice, right? That's all I'm getting at. That's kind of the whole point of dynamic programming, obviously. And I think on Grind 75, we haven't really had any dynamic programming problems that are actually that complicated, except for maybe climbing stairs, really like our first introduction. So if you feel a little bit lost, it's okay. Don't feel bad. Because I don't think we've done dynamic programming really on Grind 75. So this is kind of like when we're starting to get a little bit into it. But anyways, so we want to fill out this array basically. And this value here that we're going to solve and replace with something, if we can have some combination of coins to make amount, this value here is the important one, right? But we need to solve everything else because, again, we might need to use something from somewhere else in order to solve this value here, okay? So just bear with me, right? I'm going to go through this, okay? So we need to check every coin, by the way, for every amount, okay? So 0th index, right? That's our base case. It's already solved. So we're going to start here, okay? The amount we need to make is 1, okay? Current amount is 1. And we're going to go through this array. So we're going to first use this 1, right? The 1 coin, right? This is a coin. And we're basically going to use this formula here, okay, to basically do our calculations. So we're going to say the DP of the current amount of 1, right? We're going to set that to something. And the way we're going to calculate what we set it to is we're going to do the minimum of DP of current amount. So DP of 1 is infinity, right? Because that's our placeholder. Okay, that's infinity. What's the minimum between infinity and 1 plus DP, current amount minus coin? Well, if we do current amount minus coin, that's 0. So DP of 0 is 0. Okay. Well, what's smaller? 1 plus 0, which is 1, or infinity? Well, 1 is smaller, obviously. Okay. So we're going to do here. We're going to replace DP of 1 with 1. Okay. Nice. Oops. I don't know if I can. There you go. Okay, there, I deleted it. Okay, but again, remember I said we're gonna iterate through all coins, right? So now we're gonna subtract, not 1, but 2. Okay, we're gonna do 2 now. So we're gonna do 1 minus 2. Again, okay, now we have a negative number, so we're actually not gonna do anything. What about, let's move on to the 5, 1 minus 5, that's a negative number. Okay. Now, why do we check all the coins, by the way, is because we could have, like, I mean, I'll go to the next index, actually, it'll answer that question for you. This is a little bit hard to delete. Okay, let's move on to the next index. Okay, so 2. Current amount we need to make is 2 with the coins. Okay, let's start with coin 1, right, which is the coin. Okay, so minimum between the DP of 2, which is infinity, minimum between infinity and 1 plus the dp of 2 minus 1, which is 1. Okay, 1 plus the dp of 1 should give us 1. Or sorry, 1 plus the dp of 1. The dp of 1 is 1, so 1 plus 1 is 2. Okay, what's smaller, infinity or 2? 2 is obviously smaller. Okay. Now, again, we need to check the other coins, right? So we're going to do 2 minus, and now we're going to check the 2 coin. Okay. Now, we're going to check, we're going to do this, okay? So let's do this formula. So dp of 2 is actually 2 this time, not infinity. We replaced it. And we're going to do 1 plus dp of current amount minus coin. Current amount minus coin is 2 minus 2. So that's 0. So dp of 0 is 0. Okay, what's smaller, 2 or 1? 1 is smaller. So this actually gets replaced. That's why we have to go through all the coins. And that makes sense, right? Like just logically, because if we have to make up this amount 2, we only need 1 coin, which is the 2 coin, right? Because when we're at the 1 coin, obviously we need 2 1 coins to make up the amount 2. But when we're at the 2 coin, we need less coins. We could just use a 2 coin to make up 2, right? So yeah. So that's basically what we're doing. And we're building up the array like that, basically using all these coins for every position. And you see how we're using previous stored examples to help us calculate what the minimum is, right? And so our array is actually going to look like this. 2 2 2 2 1 2 2 3 3 2 3 3 2 3. Okay. And again, this is the important part of the array, right? I mean, it's all important because we use it to do our calculations, but this last index is the most important because, again, we're finding the whole point of this problem is what is the fewest number of coins that we need to make up amount, and amount is our last index always, right? So yeah. Now I'm going to show you an example where we actually can't use coins to make up amount and what that would look like. Okay. And that would be here, okay? So we're going to start at this 1 here, okay? So we have 1 minus, we're going to do minus the coins, right? 2, this is a coin. Okay. So dp of current amount, so dp of 1 is infinity. And we're going to compare that to 1 plus dp of 1 minus 2. Well, actually, we can't even do this, right? Because this would, 1 minus 2 gives us a negative number. So we actually wouldn't even do any of this checking. So we would skip this and leave this as infinity. Okay, now let's go here. Okay, so we're going to do 2 minus the coin, which is 2. Right, this is a coin. Okay, so dp of current, which is infinity. What's the minimum between infinity and 1 plus dp? Current minus coin is 2 minus 2, so that's 0. So dp of 0 is 0. Okay, so 1 plus 0 is 1. Well, what's smaller, infinity or 1? 1. So this replaces this, which makes sense, right? Because to make up the amount 2, we can use 1 2 coin, right? Obviously, pretty simple. So now we're moving on to this final index, which is what we care about, right? Because again, what this problem is asking is how many 2 coins can we use to make up 3? And if we can't, we have to remember return -1. Okay, so we have 3, okay, and we're subtracting 2, which is a coin. I put this C here just so you know that it represents the coin so you don't get confused. Okay, so dp of 3 is infinity. What's the minimum between that and 1 plus dp current amount minus coin, so dp of 1. dp of 1 is infinity. Well, the problem here is 1 plus infinity is obviously, you remember in math class, is just infinity. So when you have infinity and infinity, there is no minimum. So this is actually going to remain infinity, which makes sense, right? That's why infinity is there in the first place. It's like our placeholder. Because we can't use any combination of 2 coins to make up the amount 3, okay? And so this final value remaining as infinity basically lets us know that we have to return -1. Whereas if it's not infinity, we just return whatever the value is because that's the amount of coins, the minimum number of coins needed to make up the amount. Like for example, the amount 11 here, we need 3 coins to make up that amount, right? Because again, we would use a 5 coin, and a 1 coin to make up 11. Okay, but here it's infinity, right? Because we couldn't solve it, so we have to return -1, which is what we should expect. Okay, so this is how we're gonna program this. Okay, we're gonna make our DP array. Okay, and it's going to be of size, remember, amount plus 1, and we're going to set it to int max. Okay, remember, DP of 0 is our base case that gets set to 0. Okay, now here's where we're going to say int current amount, and again, DP of 0 is 0, so we don't need to start at the current amount of 0. We want to start at 1. We're going to say current amount is less than or equal to amount, because again, we want to go through the entire array. We're going to say current amount plus. Okay, and then here we want to check for whatever current amount that we're on. We want to check every single coin, right? But again, when we're checking each individual coin, we need to make sure it's when we take current amount minus coin, it should be greater than or equal to 0. Okay, because we don't want any negative nonsense. Okay, so we're going to say if current amount minus coin is greater than or equal to 0, that's good. But we also want to do DP of current amount minus coin is not equal to int max, right? And this second part here, the reason we need this is because we have to check for reachable value to prevent overflow, right? Because this isn't Python where you don't have to worry about overflow. It's a C++, so overflow does matter because and the reason we have to do this is because we're doing 1 plus this, right? Well, consider this value here, right? Where we do 1 plus the DP of 1. Well, if we're doing infinity plus 1, that's going to give us overflow, right? Because int max is the maximum integer allowed, right, in C++. So when we add 1 to that, we're just going to get overflow. So this here is basically saying, okay, when we check DP of something, we need to make sure that that something is actually a value and not infinity. Because if it's infinity, right, we're obviously can't solve the current index that we're on anyways. So we don't want to cause any integer overflow. That's the point of that. Okay, well, that makes sense. So again, here's our formula, right? Remember, for the calculations, we're gonna take the minimum. Remember, the minimum of what? The minimum of the current amount, basically where we're at, and 1 plus the DP of the current amount minus the coin, right? This right here, okay? Or this right here. I just scrolled up because this has some markings. But yeah, this is what we're doing now. Okay. Boom. And here we want to just return the DP amount. I mean, I guess you can kind of write it. I don't know. It depends how short you want to write, right? You want to say basically, if DP amount, right, is not equal to int max, then that means we actually could solve the problem. Because remember, if we can't solve the problem, the last index is going to be infinity, or in this case, int max, right? Because we're in C++. So if it's not equal to int max, it means we could solve. We actually were able to calculate the minimum number, the fewest number of coins needed to make up amount. So if DP amount is not equal to int max, right, then we can just return DP amount, right? Else means that the last value in the array is infinity or int max, in which case we want to return oh, this is not changed, this is coins. If this else means the last value in the array is int max, so we want to actually want to return -1. Got my type here. Okay. Boom. Now this is kind of messy. Obviously, if you want, you can just do return DP amount, right? Int max, right? If that's true, then return -1. Else return the amount. If you want to do a one-liner like that, that's fine. But yeah, this video is a little bit long because I just want to make sure I explain the actual, like, go through the actual example of what this algorithm is doing, because I feel like other videos explain what the algorithm is doing, but they actually don't go step by step uh in the examples, right? So, anyways, I hope this was helpful. And yeah, like I said, DP is actually DP dynamic program is one of the harder subjects in LeetCode. So, uh, yeah, don't feel too bad, right? Just keep on practicing. I definitely struggled with this problem when I first encountered it. So, anyways, I hope this helped, and yeah, I'll see you in the next one. Peace out.